So we want to see where the product property for logarithms comes from, or we want to see why it's true. So let's start with the property. The product property says if we're taking the log base b of a product, so if this is m times n, so the argument here, the argument contains a product, and that's actually going to be equivalent to log base b of m plus a second logarithm, log base b of n. So this is what the product property says, but we want to go through a little mini proof of why this is true. Why this is true. So again, we see that we have multiplication here in the argument. So I'm going to rewrite m and n. And I'm going to say, well, let's let m be some exponential function. And since the logarithm is base b, I'm going to choose a base of b here as well. So let's say that m is actually b raised to some unknown power. Just call it x. And let's also say then that n, the second piece of that argument, is also a base of b raised to some power. I'll call it y. So they're both little exponential functions. So now let's see what this looks like when we rewrite log base b of m times n, now that we have another way of defining m. So that'll give me log base b. M is really b to the x power times n, which now we'll replace with b to the y power. But now you see in this argument here we have multiplication and we have the same bases. So we'll use our property of exponents, which says that we can actually add the powers or add the exponents. So this would be the same as log base b of b raised to the x plus y power, now that I've added my powers or added my exponents. But we know that our inverse property of logarithms, which says that the base of the logarithm, when it is equivalent to the base in the argument, then these essentially are going to be undoing each other. That's that inverse relationship. And we'll be left with just the exponent. So that means log base b of b raised to the x plus y power is actually just x plus y. So now we need to figure out what is x. So if we go back to our original statement here, our let statement, we said let's let m be equal to b to the x power. So if you take this statement and rewrite it in logarithmic form, that would be the same as saying log base b of m is equal to x. So now we know what x is equivalent to. X is actually log base b of m. And likewise, we can do the exact same thing for our second statement here. We said n was equal to b to the y power. So rewrite that in log form, and that would be log base b of n is actually equal to y. So now that we know what y is equal to, then we would say x plus y really becomes log base b of m plus log base b of n. So now, taking a look at what we started with log base b of m times n, where we had multiplication in the argument, and now we see that that's actually equal to these two logarithms being added to one another. It's a sum, and it's the m, log base b of m, plus log base b of n. So the product in the argument actually becomes the sum of two logarithms. And this is why the product property for logarithms works the way it does.